In my Pascal's triangle video, you had a small glimpse on what the binomial theorem is. Essentially, it is used to expand binomials raised to any power. The binomial theorem says, for any binomial a plus b to the power n, this is equal to the sum from 0 to n. You have n choose k times a to the power n minus k times b to the power k. It looks a bit complicated, but let's continue with it. So you have the binomial a plus b to the power 3. Well, let's just rewrite the binomial theorem. You have the sum from 0 to 3. You have 3 choose k times a to the power 3 minus k times b to the power k. Now we can rewrite this. When k is 0, you have 3 choose 0 times a to the power 3 minus 0 times b to the power 0. Plus, when k is 1, you have 3 choose 1 times a to the power 3 minus 1 times b to the power 1. Plus, when k is 2, you have 3 choose 2 times a to the power 3 minus 2 times b to the power 2. And when a is 3, or when k is 3, 3 choose 3 times a to the power 3 minus 3 times b to the power 3. Now if you guys have forgotten your combinations, say you have a combination n choose r, this is equal to n factorial over r factorial times n minus r factorial. Now we can plug this in. 3 choose 0 is just 3 factorial over 0 factorial times 3 minus 0 factorial. Well, 3 factorial is 6, 0 factorial is 1, and 3 minus 0 factorial is just 3 factorial again, which is 6. Meaning 3 choose 0 is just 1. So you have 1 times a to the power 3 minus 0, which is just a to the power 3, times b to the power 0, which is just 1. Plus, alright, well, 3 choose 1 is just 3 factorial over 1 factorial over 3 minus 1 factorial. Well, 3 factorial is, again, 6. 1 factorial is 1, and 3 minus 1 is 2. Factorial is 2. Meaning this is 6 over 2, which is equal to 3. So then you have 3 times a to the power 3 minus 1, which is just a to the power 2, times b to the power 1, which is just b. Next, you have 3 choose 2. It's just 3 factorial over 2 factorial times 3 minus 2 factorial. Sorry, factorial is outside the 3 minus 2. This is equal to 6 over 2 times 1 factorial, so 2. So this is 3. Plus 3 times a to the power 3 minus 2, so a to the power 1, which is just a, times b to the power 2. Then you have 3 choose 3 factorial. 3 choose 3, which is just 3 factorial over 3 factorial times 0 factorial. Well, this is the same as 3 choose 0. So then you have 1 plus 1 times a to the power 3 minus 3, which is just a to the power 0, which is 1, times b to the power 3. And now here we have our expansion. A to the power 3 plus 3a squared b plus 3ab squared plus b cubed. Alright, that was a bit tedious, but let's do another one. So you have the binomial 2a plus b, and you raise it to the power 4. Alright, well, we can use binomial theorem again. We'll just rewrite it. You have the sum from 0 to 4. You have 4 choose k times a to the power 4 minus k times b to the power k. Well, what's a? A is, in this case, 2a. So we can just rewrite this as 4 k equals 0. You have 4 choose, rewrite that. 4 choose k times 2a to the power 4 minus k times b to the power k. Alright, well, when k is 0, you have 4 choose 0 times 2a to the power 4 minus 0 times b to the power 0 plus 4 choose 1, which when k is 1, times 2a to the power 4 minus 1 times b to the power 1 plus 4 choose 2 times 2a to the power 4 minus 2 times b to the power 2 plus 4 choose 3 times 2a to the power 4 minus 3 times b to the power 3 plus 4 choose 4 times 2a to the power 4 minus 4 times b to the power 4. Well, 4 choose 0 is just 4 factorial over 0 factorial times 4 factorial. And this is just equal to 1. So we have 1 times 2a, looks like a 12. 1 times 2a to the power 4 times b to the power 0, which is just 1. So this is actually 16a to the power 4. So the next one is 4 choose 1, which is just 4 factorial over 1 factorial times 3 factorial. So this leaves us 4. So you have a coefficient of 4 times 2a to the power 3 times b. And now you have 4 choose 2. 4 choose 2, which is 4 factorial over 2 factorial times 2 factorial. Alright, well, the top is 24, the bottom is 4, meaning you have 6. This is 6 times 2a to the power 2 times b squared plus 4 choose 3, which is just 4 factorial over 3 factorial times 1 factorial, which is just 4. So this is plus 4 times 2a to the power 1 times b cubed. Last but not least, plus 4 choose 4. Just sneak it right here. Which is equal to 4 factorial over 4 factorial times 0 factorial, which is just equal to 1. So plus 1 times 2a to the power 0 times b to the power 4. Now we can simplify this. And we get 16a to the power 4 plus 4 times 2a cubed. Well, 2a cubed, just 8a cubed. So 32a cubed b plus 2a squared is just 4a squared, so 24a squared b squared plus 2a to the power 1 is just 2a, so 8ab cubed, and 2a to the power 0 is just 1 because anything to the power 0 is 1, and then plus b to the power 4. And here you have your expansion. So you could do this with any binomial. You could have 2a plus 2b, or 3a squared plus 4b to the power 4, and all of that to the power 300. Now remember, binomial theorem is not as efficient as Pascal's triangle, which you should watch. It's very helpful. But it's still pretty efficient.